Hey folks, we're going to get underway. Our first speaker is all the way from the US, Josh Devlin. He's here to talk about, he's from Brooklyn Data Co. He's quite prolific actually on dbt Slack. Whenever I seem to have a question, he's probably about 5 minutes away from answering. I'm sure you probably have experienced the same. And he's going to be taking us through an introduction to dimensional modeling. It's right here in front of me, so that makes it really easy to provide that intro tonight. I guess we had a bit of a chat at the last meetup down at, where was it? Where was the last meetup? SafetyCulture. Not SafetyCulture, it was the one in between. It was Nearmap, yeah. And a few of you requested some modeling talks. So we've got two awesome modeling talks, one from SafetyCulture later tonight. So that'll be really awesome. But yeah, keep those suggestions coming through because, you know, potentially it might happen. So without further ado, Josh, take it away. Round of applause.
Thanks. So I'm Josh. I'm from Brooklyn Data. I'm a senior analytics engineer at Brooklyn Data. And Brooklyn Data is a full-service fractional data team for some, full data team for others. We're basically a data consultancy, mostly based out of the US. We have employees in the UK and Europe and Africa and South America as well, but most of our clients are US-based. And I've joined the company in the US, but recently returned back home to Australia and have brought Brooklyn Data with me. Today, I'm going to be talking about the fundamentals of dimensional modeling. So to start, we're going to define data modeling itself because dimensional modeling is part of data modeling. So data modeling is the process of taking raw data and transforming it into a useful form for analysis. And really, it's the design that we focus on, so not the execution. So if you think about taking the raw data A to the transformed data B, we're not talking about like how to get from A to B as much as we're talking about like what does B look like, right? So what's that design? So then what is dimensional modeling? Well, dimensional modeling is a specific system for data modeling that is built on the core concept of facts and dimensions, okay? So it's known by a few other names. So known as star schema. This diagram, the little blue boxes are tables. It's like an entity relationship diagram. The little black lines are showing the joins. Looks vaguely like a star if you squint. It's also known as snowflake schema. You're going to have to squint a little bit harder, but it kind of looks like a snowflake. Not that we see many of them down here. Also known as Kimball, named after Ralph Kimball, who wrote this book in the early 90s, and we're going to talk a little bit more about the context in which he wrote it a little bit later. But first, facts and dimensions. So when I first started modeling data, I was really confused about facts and dimensions. I couldn't really work out, I read lots of different things. I couldn't really work out what was a fact and what was a dimension. And confusingly, sometimes there are things that you could argue are facts or dimensions, like subscriptions is like the classic one that you kind of have to make a choice when you're modeling it. Anyway, what I'm hopefully going to do today is give the explanation that I wish that I had when I started modeling data. Okay, so we're going to start with facts. So a fact represents a business event. So it might be, depending on the business, it might be the act of a user visiting a web page. Could be someone like an appointment occurring, like an appointment between a patient and a doctor, say, or it might be making a sale is the most typical one, right? And it's always associated with a measurement. So how many or how much? Sometimes that measurement is one, right? So in the case of like visiting a web page, the count of that is just one. And if you're making a purchase, you have a dollar amount. If you're making an appointment with a doctor, you probably have a duration. You probably have a dollar amount as well. And usually facts happen at a specific point in time. There's a little bit of variety here, but they're usually something that occurs, right? So an appointment occurs, there's a moment that you visit a web page, there's a moment that you make a purchase, okay? Now, dimensions are objects that help you understand facts, okay? So these are entities, they're the who, the what, the where, why, how of entities. And unlike facts, dimensions persist through time, and often they evolve over time. And we're going to talk a little bit more about that later, but we're going to start with an example to help you really understand what a fact is and what a dimension is. So we're going to imagine that our business is a department store like Maya or DJ's, and we're going to think about business events, and the most important business event that happens in a department store is when you give them money, or at least as far as they're concerned. So we're going to start with the sale, or we're going to call it order, because it's going to make more sense when I build a sentence in a second. So this square is a table. The blue text is its name, so fact order, which is abbreviated. And you can see there is a unique identifier. You can see that there's a measure, okay? So the amount is the measure here. And you can see that it happens at a specific point in time. It's got a date attached to it, okay? And we can do some interesting analysis with this, right? We can look at revenue over time. We can look at total revenue, but then we kind of get stuck. So to do more, we need more information, and that's where we need to bring in a dimension. So let's bring in customer. So customer places an order. Okay, so now we have a customer dimension. Okay, it has 4 columns, it has an ID and some information about the customer. And you might notice that the order table now has a new column. It has a foreign key, a customer ID, and that's how they join. So when you're writing your SQL queries, you can join them together. Note that a customer doesn't have a point at which it happens. A customer just exists. You can have dates associated with dimensions. You can have the date of the customer acquisition, or you can have last purchase, but they're not when the customer happened. They're attributes of the customer. Okay. Next, we're going to add products. So customer orders product. So we've got product ID, product name. You can see it joins back to the order table again. And we talked about dimensions evolving. So dimensions can evolve over time. If you think of this product, its name might be revised, its brand might be revised. You had a supplier column. It could be that suddenly you get a product from a different supplier because some deal was made upstream, or someone bought someone, or something like that. Okay, next, employees. So this is actually the how of the what, where, why, how. So the customer is the who, the product is the what, and now we're looking at the how. So employee makes a sale, customer orders product from employee. And you can see now our fact table is starting to get a bit wider. Note that dimensions here, just for the example, they don't have a lot of columns, but typically they do. So dimensions tend to be quite wide tables. By wide, we mean columns go across, and so that gives the table width. But the examples here are just nice and short. And finally, we have a location, the where. Okay, location, name and address, and an ID. So you can see our fact table has got lots of foreign keys in it, and it's got some measures, and the rest of the data is stored out in the dimensions. And you'll notice we're starting to look like that star, that squinty star that we talked about earlier. Okay? Okay. Now, my favorite thing is history lessons and how things happen. So we want to put this dimensional modeling in its context. So we're going to start in 1996. Kimball writes this book, the Data Warehouse Toolkit, which is the beginning of data modeling. And for quite a few years, this is it becomes popular and it remains popular. And 1996, the data world and the technology world looked a lot different to what it looks like today. But this worked quite well, right? Fast forward, 2012, Redshift comes along. Arguably the first data warehouse, certainly the most popular early data warehouse and sort of ushered in the modern data stack era. A couple of years later, BigQuery, it was around kind of at the same time as Redshift, but they used this really weird, obscure SQL syntax. They decided to adopt the SQL standard in 2016 and started to then become more popular. In 2017, this tool that you might have heard of, dbt, emerges out of Fishtown Analytics and starts to become more popular for transforming data in your warehouse. And then 2019, a couple of years ago, Snowflake gained some momentum. Snowflake kind of around in like 2012, 2013, they were in stealth then. And they came out of stealth and started to really like pick up speed over the last 3 or so years. So the point of all of this is to show you that there's pretty much 2 decades between like the data era that we're in right now and the data era that dimensional modeling was sort of created for. So the obvious question is dimensional modeling still relevant in today's world? So to answer this, I'm going to look at what I think were Ralph Kimball's motivations for coming up with dimensional modeling in the first place, the problems that it solves. The first one is he wanted to create a system that would support returning results to business users fast. And this was really embedded in the technology of the day. It was relational databases, columnar databases didn't exist. Everything was on premise. I was just thinking about this earlier today, like things were expensive, but there were also really real constraints, right? If you needed more storage, you needed to install a hard drive in your server, right? There was no like, just keep going, Snowflake storage is endless. Similarly with compute, you needed to manage that yourself. So there are a lot of details in the Kimball method that are about being efficient with storage and with performance. The second motivation was like a system for presenting data for analysis that makes sense. And these kind of go hand in hand, but the world has changed, the technological world has changed, the technologies that we deal with has changed. And so I've heard and read folks say that we don't need dimensional modeling anymore, but I really think that we do because it's such a clear way of structuring that data for analysis. But yes, dimensional modeling is definitely relevant today. Okay, so as I said, data infrastructure has changed, but our need for organizational structure has not. And we do need to discuss some of Kimball's system, but we can keep the big picture and the main ideas. So in summary, dimensional modeling is a system for designing data and structuring data for analysis by separating things out into facts and dimensions. And facts are business events, dimensions are entities. And even though it originated nearly 30 years ago, the structure is really useful for today. We need to remember that the nuances of his approach are less important than the big picture and focus on those broad principles. To finish, some reading recommendations. 3 books. Obviously, Ralph Kimball's book is the classic and definitely recommended reading. The second book is quite interesting, provides a very opinionated system for gathering requirements for dimensional modeling, kind of discovering facts and dimensions and that sort of thing. The third book is my particular favorite because it was reading this third book that things finally clicked for me in dimensional modeling. It's called Star Schema, the Complete Reference by Christopher Adamson. All 3 of these books were still, I mean, some of them obviously, but all 3 of these books were written and predate the modern data warehouse. So all of them, you need to ignore things. And in fact, the Adamson book that I really like, I reckon you can kind of tear the second half off and not worry about it. But there's still lots of value in that first half. And that's all I have.
Awesome, round of applause. So we've got some awesome prizes tonight, actually. Kelly's been kind enough to bring a couple, two, in fact, for the best questions of the night. So if any of you would like to ask Josh a question about dimensional modeling, far away. John.
So one of the things I like about the dimensional modeling, I'd like to write it avoids slightly different things. Like if someone puts an address of 400 Elizabeth Street, and someone puts 300 Elizabeth Street, there's only one place where it's the correct address.
You would do that.
I guess Kimball liked it because it used less data storage, which is probably what you're suggesting is models relevant today. But are you suggesting that having that single reference point leads to less errors?
So I don't think for me that's a huge motivation in my love of dimensional modeling, if I can put it like that. I think like what you're describing is often seen in the kind of snowflake type style, where rather than have a like in my example we had product and brand, and I put the brand directly in, you would see like a brand ID and then a brand table, and that's like called snowflaking because it's what gives it that shape. And that is good for the like referential integrity. But I think it's often easier. There's always it depends, right? But I think it's often easier to build a wider dimension table, which does repeat that, and use things like testing to keep that that integrity in check.
Can have a beanie, John.
Good for winter.
Any other questions?
Yeah.
Thanks for that. That was great. You mentioned there were some nuances that we can dismiss or disregard. From your experience, what are some of these that you've seen that you've disregarded?
Yeah. There's lots of details. I've been doing a lot of thinking at the moment about how what to kind of step back. When I first started learning, I had no way of telling what was useful and what wasn't to me. And I have built up that intuition over time. But when people start, you say, oh, read the Kimball book, but ignore some of it. But I can't really tell you what to ignore, but you'll work it out, right? And so what I've been thinking a lot about recently is like, how do we give folks that are starting out the intuition to know what to ignore and what not to ignore. I'm still working on it. The best that I've come up with so far is to like focus on the large concepts and not the implementation details. So the one that always comes to mind is the like Kimball says you should have an integer ascending primary key, right? And you just need something that's unique, right? You don't need to bother yourself. And you see occasionally someone will get like really caught up on, especially dbt, which is, it's not easy to create an integer key in dbt. People are like, oh, how do I do this? I need to do this because it's the Kimball thing. And so, yeah, it's something that I'm doing some thinking about, like how can you give people that intuition when they don't have the intuition? So how can you give them a rubric for deciphering that?
Do you need your book? Do you have a book in you?
I don't know. I thought there was. Oh, this is being recorded, so I got it. Yeah, I think a few people have attempted to be the book, but yeah, I think there needs to be a book, or at least a central resource.
21st century.
Yeah, it is needed.
So we talked a bit about dimensional modeling and Kimball, but what are the alternatives?
Well, in the next talk, you're going to learn a little bit about one of the alternatives.
No.
Well, sorry, yes. Yeah, I should reject the premise of the question.
They make a great politician.
Yeah, they can be complementary, but Data Vault is in like today's era is the other really well-known data modeling concept. In Kimball's era, there was Bill Inman's concept of a data warehouse, where like warehouse is kind of in air quotes, which is like building out a very relational data model that like re-represents the whole business. So the way I think of it, and maybe it's not quite correct, but the way I think of it is like, imagine a production database, but imagine you had a database designed like that represented your whole organization. And so constructing it like that. But I feel like, I don't know for sure, but I feel like that may have sort of gradually fallen out of favor, although he doesn't stop him from posting rants on LinkedIn.
He supports data vault.
Does he?
Yeah.
Interesting. Well, I think Josh will be around afterwards. We'll have a bit of a half an hour to have a bit of a chat afterwards. So round of applause for Josh. Right, we're going to continue the live stream, do a quick changeover to Oscar from SafetyCulture. Feel free to grab some more food up the back if you like.
Yeah, go ahead.
Oh, you're on. Oh, okay.
Let's see what she's like now.
How is the food tonight? Good? Yeah. That's awesome. Such courage for presentation.
Yeah, one more courage beer, it's fine.
Have you got? Oh, there you go.
Yeah. Oh, yeah, yeah.
Right. Are you sharing your slides, Oscar?
I am.
You are.
Oh, no, sorry, on the stream.
No.
Yeah, I got it. I was a bit confused.
I'm gonna sit right in
Like this?
Yes. Fantastic. Make data, create a game.
Yeah.
Sorry, now you can watch what's up.
Yeah, you can.
You're welcome. What's the view that
I'll do it. All right.
Sorry, I'm just right in the.
We've got the SafetyCulture cheer squad right here tonight. This is awesome. Makes and everything. I was actually here for the first one.
Oh, okay, fair enough.
Do you really wanna? Off the back, we're gonna dive straight into it if you like. We've got Oscar Lukersmith, lead analytics engineer from SafetyCulture tonight, and joining him is Justin Lane, data architecture and modeling from SafetyCulture. They're gonna take us through making data great again at SafetyCulture. Fresh from
Hawaii.
Fresh from the Hawaiian trip.
Yeah.
So should be a
Actually,
good one.
I missed a trick because I should have said make analytics great again, and that would have been Margaret, but anyway. So yeah, it's a bit of a weird title, but today, well, to explain a little bit, I feel like it's a bit of a personal title for me because I started at SafetyCulture 4.5 years ago actually, and we've grown from I think 180 to 800 people now, and so back then in our analytics team we had 3 or 4 people. One of them's here, Chiago.
I didn't start that time.
Okay, whatever. Off on a good start. Anyway, so back in the day, we had this, we were a very small team. We had a lot of stuff to do, a lot of people to answer questions for. And so we actually had this very interesting stack of a little bit of Airflow, a little bit of Looker, and a Frankenstein data model. And so about a year ago, we hired a whole bunch of new people, many of who are here, and we decided to rebuild our analytics stack, rebuild our transformation layer. And so this talk is really taking you through how we did that and what we designed and how we implemented it. We were kind of a bit of an interesting team because we don't have analytics engineers except for me. We have the analysts actually build most of the transformation layer. And so that presents kind of an interesting problem in itself that the businesses are expecting output from the analysts, but we're trying to rebuild our infrastructure in the background. And so, yeah, this talk is specifically for those types of situations where you need to balance competing priorities and everything like that. So what we're going to cover is what is safety culture, bit of the business problem and context, the team, and then we'll go through our design phase. So we had quite a robust design phase initially, and then the implementation phase. Design phase probably took about a month or two, and the implementation was probably about 5-6 months. And so what is safety culture? Well, it was founded in 2004 in Townsville by Lukersmith, and it was a safety documents business. They used to sell boxes of paper documents to businesses. But then in 2012, they launched iAuditor, which is why it's called iAuditor, because it was 2012 and everyone stuck an eye on things. But in 2019, we sort of pivoted to be more of an operations platform. So we were a checklist app, now what we call an operations platform. We're currently 800 staff across the world, and we've recently started growing by buying other companies, which kind of plays into this because if you're buying a lot of other companies, it's kind of M&A. There's a lot of changing source systems and all that sort of stuff. Interesting data environment. And we've also started an insurance business, also interesting data. And we recently got back from Hawaii. I gotcha.
Great place.
Yeah. And so more locally, like as I said, we had about 4 people in the beginning when I started, but now we invested in our analytics, thankfully. And so I think the interesting thing to note about the team is that it's kind of a medium-sized data team. It's kind of not small enough that everyone does everything. There's roles and responsibilities, but it's not big enough to necessarily have like a superset structure. And I think that plays into how we did the project. So we've got data engineering, and then we've got the analysts, and then we've got me, the analytics engineer. We've also got an open position for analytics engineering, which I'll talk about later. We've got a visualization lead, Alex, and we've got a data modeling lead. Yay. And so we've got like good skills, right? So this is the team that worked on this project over 7 months. Just before we started the project, our VP went around and spoke to 38 different stakeholders, and we got a bunch of different feedback, and none of it was particularly good. Most of it was pretty shit, actually, which is fair. But essentially, like, we identified 5 key themes, and this really informed our requirements building and really motivated us. So the requirements. We needed a trusted single source of truth, which is such a buzz phrase. But basically that comes back from, we had 2 different systems doing transformations. We used Looker PDTs, which are great and terrible at the same time. And we also had stuff in Airflow. And so there was no coordination amongst our transformation layer. And that ended up being that no one could understand what data they were using or what it meant. Ability to self-serve. So I think back in the day with Looker, it was really good because we probably had a similar type of profile wanting to use data. It's fairly tech-heavy people, pretty used to data. Looker's great for that. But as our business grew, probably something where we could create little data apps that were safe to play in was more pertinent. So we chose to go with Tableau, actually. We needed to do more training on data. People needed to understand the data. We needed to call the data the same thing in different places, all that sort of stuff. And the analyst should be spending less time fulfilling really basic requests and more time doing things like understanding customer behavior, proactive suggestions, or predictive modeling for churn, which is really cool because like embedding it in operational processes is what we're doing now. So internally, we decided our requirements would be, we need to be able to deliver incrementally. So we're not going to lock ourselves in a room for a year and build something crazy and then come out and deliver it to everyone. We want to deliver it over time and get feedback, iterate, all that sort of stuff. We also wanted a high level of automation because we were sick of doing manual things and spending time doing boring things. We also wanted a lowish skill barrier for development. We don't want to have to write everything in Scala. It's beautiful. A single platform. So again, we had Airflow Looker, didn't talk to each other. Even the data transformations and the data pipelines were very separated, so they didn't talk to each other. And going back to the M&A point, we need to be resistant to source changes. I mean, the M&A, yes, but also engineers love changing things upstream, so we've got to deal with that. And so we got to the design phase with those requirements.
Okay. I'm Justin. I'm the data modeler who joined this project. I joined the project in July last year, so the project was already underway. But I'm going to talk about the data modeling work that I did to support the project. I'm mindful that people, like I often see in discussion forums, questions where people are asking, you know, do I really need a data model? And secondly, which modeling method should I use? So I'm going to cover those things a little bit. I won't go into the same level of detail that Josh did. I do have the Kimball book at home. And if people were looking closely at the picture, they would notice that the one in the screen was the 3rd edition. I think I've got the 1st edition, which I think has even more stuff that can be ignored than the 3rd one. But one of the first things I did was to create this conceptual model. And the conceptual model is really intended to be like a very high-level picture of the things that we care about as a business. What are those entities? What are the relationships between them? And as I was building this, I was also writing definitions for things because I'm sure you've all had the situation where like people use different terms to mean the same thing, or they use the same term to mean different things. In SafetyCulture, for example, people would use the term asset to refer to an IoT device that was collecting measurements. But more recently, as we expanded our product, they use asset as a term to talk about something of value that a customer has, like a piece of machinery, for example. When you think about whether you need a data model or not, I would argue that you pretty much always have a data model when you're building something in the data world. The question is really the degree of effort that you put into it and the degree of formality that you apply to it. And if you're working by yourself or with a couple of people, maybe you don't need a data model. You can have the model in your head, or you can draw it on the whiteboard. But you pretty quickly get to the point where when the team expands, you know, it's useful to have a picture that you can all look at and have a common understanding of what things mean and how they relate to each other. And this is the purpose of this model. And like I say, it's designed to fit on a single page. I drew this with a drawing tool because I didn't have a data modeling tool at the time. But you don't need to even draw it with a formal notation. You know, you can sketch it on a whiteboard or whatever works for you. It does have a little bit of color coding that organizes things into subject areas. And some of these things are kind of useful also for our project. So later on, you'll see a model that we created for our integration layer. This model already started to identify what those things would be in the integration model. And the color coding for subject areas helped us kind of organize the project into manageable pieces because one of the things we wanted to be able to do was to deliver things incrementally. And by that, what I mean is like, you know, we don't want to have to rebuild things when we're adding new stuff. We want to be able to keep adding without breaking stuff. Here's a picture of like a high-level picture of our architecture. You've probably seen similar pictures before. We think of our architecture as a value chain. So in the first stage there, you see we're acquiring data from a bunch of different sources. We're doing a little bit of work to kind of standardize the data. We're cleaning, deduplicating the source data, that kind of stuff. And then we get into like our integration layer. And here we're pulling data from different sources, and we're changing it from a system-centric view of the data to like a business-centric view of the data. And in a moment, you'll see the method that we use to do that. I don't know where it's gone there.
Seth, do you want
Sorry, just self-destructing. Hang on a second.
computers? They're hard.
Yeah.
Did I do that?
No, did you, like the way you waved your hand?
Okay.
Perhaps? Yeah.
While you're fixing that, I was going to mention that I actually used to work in this building.
Really?
Yeah.
Woolies?
Level 9, NDIA. I worked for NDIA.
Oh, okay.
Yeah. And,
Woolies had this floor before. We
yeah.
did. Yeah.
Well, I think you guys were here though. I don't know. What I remember was there was one day I came to work and I got into the lift and I think I was like daydreaming a bit and I forgot to push the button. And I thought, oh, that's fine. I'll just get out at whatever floor the lift stops at and I'll be in the lift lobby. That's fine. I'll just, turn around and go back down again. But I came out here and it's like, I'm not in a lift lobby. I'm kind of in the middle of the floor. It's so embarrassing. And I'm sure people were looking at me like, what the hell is this guy doing?
You could just sat down and started working. No,
Yeah.
fine. Are you back?
You did seem to be friendly. Maybe too friendly in a way. So from the integration layer, we then take the data through into an enrichment layer. And what you'll see is that that enrichment layer is modeled using the star schema method that Josh was talking about earlier. And from there, we present data in dashboards and reports. Underpinning some of this, we have like Redshift as our database platform and dbt doing our transformations. What is going on?
Is it something?
Tell us another story about
Maybe
how
it's
you got the wrong link to the wrong floor.
Maybe it's too late in the day.
Mm.
And we orchestrate our dbt through Airflow using the Airflow API. Did I get that right, Nilesh?
Yeah.
So apart from like re-architecting our warehouse, we also did a number of things to kind of, I guess, bring a bit more formality to the way we do things, which includes things like, having a naming standard for how we name things, which we'll have a brief look at later on. So how long have you been on this?
Spinning wheel of death.
Tell us about Hawaii.
Where'd you say? Oh, we had a lot of fun. Yeah. Actually, no, we were working very hard the whole time.
I was working very hard.
Yeah. We did work hard some of the time.
Your team looked a lot fresher than my team, just saying. So.
Oh, well, there are some people in our team that are not here tonight. They're probably still recovering. Yeah.
Don't move much down.
Okay.
Yeah, I'll go around that side of the stage.
All right. Now for our integration layer, so yeah, I should mention, just going back quickly to the conceptual model, I created this from information I got from a variety of different sources. It was reading stuff on the public website, talking to analysts, reading stuff on Confluence pages, that kind of thing. And I actually used this to talk with business stakeholders as well. So I talked to people from different areas and kind of walked through the part of the model that related to their responsibility to check, that it was kind of roughly right. But that was also like a good way of kind of having that conversation with business stakeholders and finding out, what their challenges were. Sorry. Maybe we'll wake up. No?
Yeah, it's going to come back again, but my apologies. Keep going. Sorry.
The live stream's coming through. You should have all stayed at home.
You're going to edit this out, right?
Yeah.
No, actually, the live stream's actually really good.
Oh, it is good too.
Yeah, for once.
Oh, well, I'll just wait till everyone gets home. You can let me know and I'll keep going. So for our integration layer, we use the data vault methodology. Is anyone familiar with that? Put your hand up if you're familiar with data vault.
Oh, okay, the SafetyCulture thing.
I saw one from Canva.
I only heard, we haven't used it.
Yeah.
Just heard of it.
Okay, so let me try and talk fast and see.
Yeah, go for it.
In data vault, you essentially have three kinds of entities. You have hubs, links, and satellites. The hubs are just keeping a record of business keys. Business keys are the things that you use to identify something of interest. So it could be a customer or an organization or a subscription. There'll be a customer number or something that people use to identify that thing. And whenever you encounter a new instance of one of those things, you stick it in your hub. A link is a record of a relationship between two business keys. So the relationship between a customer and an organization, for example, would be kept in a link. Again, when you detect one of those relationships, you add it into the link. And so the methodology and approach is actually like pretty straightforward. Like once you've got an understanding of how it works, it's pretty simple. You just keep repeating that. The most interesting data though goes in the satellites, and the satellite is all the data that describes a hub or a link. So if you imagine that you have a hub for a customer, there'll be a satellite attached to that that has all the descriptive data that defines a customer, like their name and where they are and what industry they're in and whatever it is. One of the nice things about the data vault methodology is that you can very easily build it incrementally. And essentially what you do is you need to incorporate new data is that you can add new satellites into your model. The model that you see here is like just a very small section of our integration layer, and you can see some color coding. That the purple are hubs, the green is a link, and the orange is satellites. We didn't do extensive modeling though of our integration layer because once you've got the basic pattern, once people understand the basic pattern, they can pretty much add to this, right? We don't need to invest a lot of time in modeling for that. And let me just show you here, there's a nice animation that Oscar created for me, which sort of demonstrates like how we built this. So for example, we could create a hub for the user IDs that were coming from our iAuditor app and a hub for the subscription IDs. And then we could create satellites that had all of the descriptive data for those things. Later on, we have data coming from another system that relates to an acquisition that SafetyCulture made. So SafetyCulture bought the header company, which brings a lot of similar but different data. And we could attach that into this model without having to rebuild anything that we'd already delivered.
What does it give you beyond, like it seems like you've separated your primary keys from everything else now?
The TV was working.
So in your integration layer, essentially what you're trying to do is take the data from like a system-centric view to a business-centric view, because of course your business users, like they want to see data about their customers, and they don't care if it came from Salesforce or from your internal system or from some external source. All of those systems will typically assign their own ID to an instance of the customer. And what this allows you to do pretty quickly is to be able to combine all of that data.
Also, you're assuming that you've got some data over there that has a primary key for a customer. It's the same customer as this that has a different primary key.
Yeah, so you can create, you could have records in a link, for example, that are just doing that are telling you this customer is the same as that customer. It's also, you can create tables that are physical implementation of this model, and you can load them all at the same time. So it's very efficient in that respect. If you have schema changes, for example, that impact one of your satellites, you might stop populating that satellite and just create a new satellite. So it's very good at that sort of incremental thing. You typically don't update anything or change anything. You just add stuff, whether that be data or entities when you have new data to bring in. And yeah, so it enables that incremental delivery. Now, it does mean you end up with a lot of tables, and so it's difficult for people that are not competent with SQL or whatever tools you're using to consume that data. But someone who's a data analyst who's capable of doing that can do it, right? So you could very quickly make that data available to them, even though you haven't done all of the transformation that like a business user might expect. And then lastly, for our access layer, we developed these star schema or dimensional models. And for that, I worked with the analysts, and the analysts typically cover like a particular business area. And depending on the analyst, they had different ways of bringing this information. Some of them would draw pictures, some of them would give me a list, some of them would point me to an existing Looker dashboard. And from that, we created these dimensional models where we were clearly identifying what the metrics were that were sitting in those facts and what the dimensions were, and then all of the attributes that define those dimensions. And these things are typically materialized as you see them in the model here. But we also create like flattened versions of this as well. So I can take all of this data and put it in one flat white table in a way that's still true to this model. And sometimes we do that. And lastly, I just wanted to mention that something else that we did was we defined a naming standard. And the naming standard lives in Confluence. It's kind of made up of these components. There's a set of rules. There's a pattern for creating a name. We use class words. And the idea here is that like the name is the thing that people see typically when they're going to consume your data. So it's useful to have a name that's kind of meaningful and easy for people to know what the thing is that they're seeing, what to expect, and for those names to be consistent. So the same thing, we want to call it by the same thing across multiple data sets. You might drop the class word in your visualization to make the name shorter. But in the database, it's useful because it helps you to know, like if I'm looking at something in that column, what is it likely to be? Is it going to be a country code or a country name? And that's just a small example of applying that pattern. The pattern is essentially like a 3-part pattern. So you have a modifier, a prime word, and a class word. And that's the way we implemented that.
So you're saying the data types are part of the column name effectively?
So the class word, I'm really kind of categorizing the data into a class, but the data type is also, like as typically I'm doing logical modeling, right? So I'm not really too concerned about the data type in the database, but the data types are closely related to the class word. Yeah.
Implementation phase. So this is actually how we went about it. From Justin's modeling, how we implemented it in dbt is the first layer is aligned with our data value chain. So we have staging, integration, access, exposure. So staging, data vault, Kimball, and then the flattened Kimball models. So staging, we organize by source system because it's obviously a very source system centric view. We also decided to use only markdown files for naming. With our data modeling and how we've done things, there's a lot of repetition. And because of our naming convention, we have a lot of repeated columns. And so we want to make sure all the documentation is aligned. So the rule is markdown docs. With integration, we organize it by the table type, so hub links and satellites. And we also have the ability, well, we've decided we can have base models. So I think some people call them intermediate, but it's kind of like a half step between staging and integration for complex transformations when you want to dbt-fy them and break them apart. For access or Kimball dimensional, again, organized by table type. for exposure, where we're flattening out those access layer models, we organize by consumer, so that's the external consumer. So we use high touch. Where's my boy, Henry? And then from there, we organize by domain. So we have core models that are relevant for all of our domains. And then we have specific domain areas like product or go-to-market or something like that. And that keeps it very clean. So we kind of realized that, in retrospect, I realized that we had 3 very distinct phases for our build. So we had the initiation phase, we'll call it. And so what that was me working with one of the analysts who's not here. And we decided to build an exposure model, start to finish. So all the staging, integration, access, exposure. And that was to learn. And so we figured out the real basics. So what was the pull request process? What was the CI/CD strategy? Making sure the element naming standards, what jobs we needed, all of that. And then we also worked out how myself, he, Justin, we all worked together. You know, we were a new team with lots of different skill sets, and we weren't sure how to build together. And so we worked out who did what. What we learned is a basic workflow is very easy in dbt, Airflow, whatever, basic. And then everyone working closely together avoids rework. So we had an instance where what Justin had modeled and what we built were completely far apart. And so we had to rebuild it. And so having close contact with Justin and the data engineers was really helpful. And then we noticed that there were like 3 essential steps for our migration. The first was like, as Justin said, we did a high-level data model design. But then when we went to go build a specific subject area, we went detailed. And that was really a requirement. But then we went on to the data build. So that was actually building the transformations. And then we had like a dashboard build or a actual like the presentation layer build. And then after that, we scaled it out. So there were 6 other analysts. And so what we did was onboarded the other 6 analysts into dbt. And we had dbt hosted training. I think it was Amy. That was really good to like learn the basics of dbt. But then we were missing the context of how we had applied dbt in our world. And so I did some training for the analysts, group training. But then I also pair programmed. So we gave each of them like a model to build or something to build, and then I sat with them and helped them. And then we had office hours all the time. When we actually started doing the work, we implemented sprints. The parallel workflow I'll get to, but it's sort of related to how we had to keep delivering to the business while building this other system, right? And so that's very related to the design and requirements, the data build, dashboard build. So then what we did is we decided we're going to prioritize the highly utilized core dashboards. So what I mean by that is like the company metrics dashboard or the single customer view. They were relevant for everyone in our business, so we prioritized building them. But then the real goal was to have the highest impact for the lowest effort. And so we prioritized teams who had a low amount of dashboards, but a high amount of people, right? Because then we could migrate them over from one system to the other. So basically that ended up being focusing on sales because they have a low amount of dashboards and like 150 people. So what we learned, implementing like a lot of testing can be really annoying and really hard. And so we decided to start from the end. What we decided was what we were giving to people, like the exposure layer, was the important thing. And so we built all the rigorous testing there, and we're slowly working backwards. When you have 7 or 8 people, I know Canva has like a lot more people developing, but we noticed that development started to slow down, mainly because as the data model got bigger in dbt, we had to refresh more in our dev environments. And then Redshift started increasing in space and all that sort of stuff. So development slowed down. And it was difficult for me at this point, because I was the only one reviewing pull requests. It's difficult for me to actually review both the technical and the business logic at the same time. We're a company of 800 people, and the amount of business logic that's across our company is ridiculous. I used to know it all, but not anymore. And the other thing we learned is everyone's really bad at planning. I think at one point, like with our sprints, we were probably hitting about 40% of what we committed to. And that was across the board. And we also learned that things will go wrong, and that's okay. But we needed to somehow figure out how we could retain the trust when things go wrong. So like changes upstream, systems going down, all sorts of stuff can go wrong. And so this is what I was talking about with the parallel workflows. And it's a bit of a confusing thing, but we've got 3 analysts here. And what I want to highlight to you is the incremental delivery. And so you can see here in analyst 2, right? We've got those 3 phases: requirements and design, dashboard and data and dashboard build. Then they go and do something else because they have other priorities for a sprint. And then they go back and do another subject area and do requirements and design. So it's very incremental delivery. The other thing is the something else, right? We could keep going with our migration process because at any one point we would have people working on it, but then also other people meeting the demands of the business. And so just sort of like slotting it in like this was useful for us. And then the final phase was refinement. So what we did to solve for the really bad planning, we implemented story points, and I think everyone groaned when we first started talking about it, but it doesn't need to be arduous. Does everyone know what story points are? Yes, cool. So we use Fibonacci story points. So 1, 2, 3, 5, 8. You assign points to the task and the Jira task. And why that was useful was because we could see who was overcommitting or undercommitting. We know that each analyst can handle about 15 story points in a sprint. And it was also very useful because, for the 15 minutes before our sprint start, people would try and assign story points. And then every now and then, they would look at the Jira task that they had created and they're like, I can't estimate this, which kind of means that the outcome or the Jira task isn't specific enough for you to actually estimate the work. So it makes you think about what you're committing to. To solve for the slow development process, because we orchestrate through Airflow, Redshift, we basically have an Airflow task that pushes the manifest to the dbt repo every day, which means we can use defer. It also means it's very useful for us to do a weekly clean. So we clean out our dev schemas every week, which saves $25,000 a year, which is pretty cool. So I'm now spending on high touch. And we implemented a peer review pull request process. So I review purely the adherence to the data model, the conventions, and also maybe some query planning, optimization, that sort of stuff. But the analysts are really empowered to review the business logic because they're the ones that know it, not me. And the other thing we did was implemented an incident management framework. So we actually just completely stole this from our engineering team, which is, I suppose, analytics engineering, but anyway. And we're still learning. We don't know what we don't know yet. Finally, I just want to look at this incident management framework. So we identified 3 key areas when things go wrong for us. So there's incident prevention. So the pull request peer review process was really good. We also implemented change freezes. So during quarter end, which is when our goals are kicking over, when people are trying to work out how much commission they get and all that sort of stuff, we don't make any changes. And we also, because we're a checklist app originally, we've got a checklist for pre-prod dashboards. But the main thing is the incident management process. This has been really successful for us. And so the main things in the incident management process is that when something happens, so to begin with, an incident for us is defined as anything that makes numbers look wrong on a dashboard, right? Or anything noticeable by a consumer. And so when that happens, we assign different roles in our team. So we have an incident commander who's responsible for the communication, and we have SMEs, and then what else do we have? Forgotten. No, that's about it. But then also after the incident, we have a post-incident review meeting, and so that's talking about what went wrong, why it went wrong, 5 whys kind of stuff. And then we assign improvement actions, which we then try and slot into our sprint planning. So that's been really helpful because we're identifying trends and trying to, we noticed that a lot of the issues we were having were actually common causes, right? And so we've been implementing proactive things to try and stop that. Finally, we're hiring. I'm looking for an analytics engineer, so if anyone knows one.
Yeah, round of applause. I've got a ton of questions myself.
Oh,
Which company isn't hiring tonight? And Henry, when can we get some high touch swag, mate?
I got some of that back.
Yes, awesome, very good. A couple of questions from me, Oscar. You mentioned Redshift storage. Are you still on the DC2s or you're on RA3s?
RA3.
RA3 still? Okay,
Yeah.
awesome. And the other question was, oh gosh, I might have forgotten it now, but no, I've forgotten. Who are you guys?
You go first.
If you guys use the default
Well, that's only for Snowflake, unfortunately. Yeah. Sorry. The dbt Vault. It's a data vault package for dbt. It's unfortunately only for Snowflake. I've kind of recreated it. I stole a lot of their code and just changed the syntax.
Oh, that was the question. With Airflow, are you sort of kicking off dbt cloud jobs or just running dbt in Airflow?
Yeah, no dbt cloud jobs. So
Yeah,
through the API, yeah.
Yeah.
So as soon as we've got sensors set up and stuff, so as soon as our data pipe, like our ingestion pipelines run, then dbt will kick off.
Yeah, nice. Really cool.
So I get the integrated layer is like very extensible. You can add new tables. How do you then make changes to the dimensional layer, where say a fact table needs to say you do an M&A and you need to add this whole lot of context for in the fact to it by dimension.
I might go back because the presentation was not doing well at that point. So going back to this thing, if we were to integrate EDA, theoretically, we wouldn't actually have to make many changes in our Kimball model. It's all in the integration layer. So if we have this set up, if we were to integrate EDAP, what we would need to do is put the EDAP IDs in the hubs, and then just connect the EDAP satellites, right? So does that answer your question? No.
And then, so the satellites would have the context, right?
Mm.
And you would want to stick them in the dimension for subscription, let's say.
Yeah.
So like you would add more columns to the dimension, to the subscription dimension?
Yeah.
Could be, yeah. I think like in terms of the modeling effort, we've put most effort into the dimensional models. And so if there were new measures that needed to be included, yeah, we would do some modeling and figure that out. Yeah.
Where possible, we would join the columns together, though, if they're a similar idea, right? Like if we had ARR for both EDA and iAuditor, they would go to the same column, right?
And if we did, like if we need to rebuild those tables in the access layer, yeah, we should have all the data easily available in the integration layer. Yeah.
Was that rebuild process quite expensive or time consuming?
Yes.
Oh,
Yes.
Yeah.
cool.
Awesome. Question up the back. Yeah, go for it.
So I'm from small
Hmm.
company, and as a small company person, I don't need to use let's see the analytics, but what happens is that Chapter is like AI, and what happens is that when I use face recognition, before what I did was just ID and employee's name, this kind of text. So it's very small. So once I have a face recognition, the database will become suddenly very big. And if my database is a 10 gigabyte, it will become 1 gigabyte. And I can't use my Lukersmith, right? Oh, so then simply database becomes big data. When the data is
It's more of a Chiago question.
You need to make friends with data engineers.
So I think that's more not much related to that dbt problem that would be you need to change some technology that you decide to, because if you're using your local machine, it's very hard to scale up and your machine will not be able to handle. So you first thing that would do, I would migrate for cloud for you, and there you can choose different types of technologies. You can use stuff like that. You can just pay when you use it. Or if you have more budget, you can find other technologies. You can use also Databricks that has a lot of AI that you can help you with that.
So I simply transition to the database storage.
That would be the first step. Then you're gonna have a lot of other stuff.
Can I get that?
Yeah, I can put with you.
Just buy him a beer or something.
One last question.
Yeah, there's two. Hands up for the segment. You mentioned going from Looker to Tableau. I haven't heard of too many people who
I'm not going to get into that. No, I think Looker's really good for, I think it's to do with the data consumers almost. So as we've scaled, we've got a lot of different data profiles, I would say. Like people want to consume things in different ways. And a lot of those people want a safe playpen that they can do a lot of cross-filtering and all that sort of stuff. And so I think that's why we made the decision, because Tableau is obviously better at that.
obviously. Okay.
We found a Looker fanatic.
One last question.
I had a question around the data quality checks. You mentioned that inconsistent data is a incident for you guys.
Yes.
So how do you go about managing the consistency from the upstream to the very end? What are the checks and balances you have in place?
Yeah. Yeah, so we have a lot of freshness tests, and we also do a lot of like regression testing, I suppose, for changes in source system data. As I said, we've been focusing mainly on the exposure layer testing. We use dbt expectations a lot, and we've started using a lot of custom testing. So there's Annabelle somewhere. Annabelle created a really cool test because we've got several models where you can calculate the same metric across different dimensions, whatever. So we've got these integrity tests cross models now. So we're checking that we're calculating the same numbers across different models. Yeah, but other than that, dbt expectations is great.
Awesome. Well, round of applause. We'll end the live stream here.